Algebra 2, this is target 31. I can solve a rational equation. This is the second part of target 31. In the first part, we looked at proportional equations and how we could solve those using cross products. In the second part of target 31, we'll look at non-proportional equations and focus on using least common denominators, okay, or LCDs, to help us solve those rational equations that are not proportional. All right, so when we have a rational equation that's not expressed as a proportion, you can solve it by multiplying each side of the equation by the least common denominator of each rational expression. All right, so if we have a over b plus c over d equals f over g, right, that would be a non-proportional equation. Okay, the LCD of this would be b dg, right, just multiplying those together, which would make, when you multiply the entire, or each side by that, okay, so you multiply this side by b dg, okay, you multiply this side of the equation by b dg. What ends up happening is when you multiply a over b times b dg, okay, the b's cancel out, right? Okay, so you end up with just a dg, okay, plus, and then when you multiply c over d times b dg, then the d's cancel out. Okay, so you just end up with c bg. And then over on this other side, when you multiply f over g times b dg, the g's cancel out, and you end up with f b d. All right, and again, now you no longer have any fractions in that equation. It should end up being some type of either linear or quadratic equation that we should know how to solve using methods that we've learned in the past. All right, so let's get into some examples. Okay, first one, we've got 5 over x plus 7 over 4 equals negative 9 over x. So if you look at the three denominators, you've got x, you've got a 4, and you've got an x. So x is just equal to x, 4 is equal to 2 squared, okay, and then x is just equal to x again. So when we find least common denominator, again, we're using the highest power of any factor that shows up. So we have an x, we have a 2 squared. Okay, we don't need the x again, so our LCD is just going to be 4x. All right, so multiply both sides of the equation by 4x. Right, so when we take 4x times 5 over x, right, those x's will cancel out, and you're just left with 20. Okay, and then plus, when we take the 4x times 7 over 4, right, the 4's will cancel out, and we're left with just 7 times x. And then equals, and when we take the 4x times the negative 9 over x, x's cancel out, and you're just left with negative 36. Okay, and as you can see now, once we do that, when we multiply through by that least common denominator, we end up with just a linear equation. So going ahead and solving that then, we're going to subtract 20 on both sides, get 7x equals negative 56, and then divide by 7 to get x equals negative 8. And again, we do need to make sure we check these answers because you can introduce extraneous solutions when we do this. So going back and checking, we'll put 5 over negative 8 plus 7 over 4 equal to negative 9 over 8. Okay, look. Sorry, negative 9 over negative 8. Okay, so you would have negative 5/8 plus, and if you use 8 as the common denominator, this would be 14/8, okay, equal to 9 over 8. And negative 5 plus 14 is 9, so you get 9/8 equals 9/8. and that checks out. So x equals negative 8 is your solution. All right, next example. Okay, we have 1 minus 8 over x minus 5 equals 3 over x. So this is a 1 over 1. So your denominators are 1, x minus 5, and x. So this is just equal to 1, right? None of these are factorable, so you just need to use each one in your LCD. So your LCD is x times x minus 5. So we'll take the entire left side times x minus 5, and then we'll take the right side times x minus 5. So when we multiply 1 times that, we get just x times x minus 5, okay, minus, and then we multiply the 8 over x minus 5. The x minus 5s are going to cancel out, and you're just left with 8x. And then over here on the right side, the x's are going to cancel out, and you're just left with 3 times x minus 5. So if we distribute, we get x squared minus 5x minus 8x equal to 3x minus 15. So this is going to be a quadratic equation, so in order to solve it, we need to get it set equal to 0. So let's subtract 3x on both sides and add 15 to both sides. So simplifying this left side, now we have x squared minus 16x plus 15 equal to 0. And then we want to probably factor that, so it'll be x minus 15 times x minus 1. Right? Because the two numbers that would multiply to 15 and add up to negative 16 would be negative 15 and negative 1. So set each one of those factors equal to 0, and you would get x equals 15 or x equals 1. Okay, and then we can go back and check them. Okay, if we do check them, we'll find that both of those do in fact work. So you have two solutions. All right, next example. Okay, maybe we want to give this one a try on your own. Okay, when you're ready, you can restart the video and I'll show you how to do it. All right, so for this one, we have 3 denominators in x minus 3, okay, x squared minus 9, and x plus 3. So the only one that's factorable is the x squared minus 9, and that factors into x plus 3 times x minus 3. So for your LCD, you need an x minus 3, you need an x plus 3. You already have the x minus 3, you already have the x plus 3, so LCD is just going to be x minus 3 times x plus 3. Right. So multiply each side of the equation by that. Okay, so when we multiply the left side, the x minus 3s are going to cancel each other out, and you're left with 6 times x plus 3. Okay, when I multiply this by my common denominator, okay, that's equal to that denominator, so all we have left is the numerator of x, 8x squared. And then minus, and when I multiply the 4x over x plus 3, those x plus 3s are going to cancel out, and I'm left with 4x, let me write it up here, I'm left with 4x times x minus 3, which is going to be 4x squared minus 12x. But now I need to subtract that, so in subtracting it I'm going to change it to adding, right? Use green here, adding the opposite of that, so a negative 4x and a positive 12x, negative 4x squared. So we have minus 4x squared plus 12x. And over here, this is going to be a 6x plus 18 equals equals, and I can combine these two to get 4x squared plus 12x. Alright, so again I'm left with a quadratic equation, so I want to get it set equal to 0. So subtract 6x on each side, subtract 18 on each side, and we get 0 equals 4x squared plus 6x minus 18. Alright, so factoring that, I can divide everything by 2 first to make it a little bit easier. So we get 0 equals 2x squared plus 3x minus 9. And then let's factor that using the box. 2x squared minus 9. Okay, so I'm looking for two numbers that multiply to negative 18 and add up to 3. So that would be 6x and minus 3x. And then factoring that, I get 2x here, minus 3 here, x here, and 3 here. So we get 0 equals 2x minus 3 and x plus 3. Right, and if I set each one of those equal to 0 and solve, I would get x equals 3 over 2, okay, or x equals negative 3. Now, however, if I put negative 3 in for x right back up here, okay, in this piece right here, if I put negative 3 in here for x, I'm going to get negative 3 plus 3 equals 0. And I can't have 0 as a denominator, so that automatically rules out negative 3 as a solution. That is extraneous. If I put 1.5 in, okay, that would actually work out, so we know that we'd find that that is an answer. All right, let's do one more. We got 2 over x plus 4 over 3 equals 2. So your denominators, you've got, this is over 1, so you've got x, you've got a 3, and you've got a 1. So none of those are factorable, so your LCD is just the product of all of them. So that's 3x. So multiply this by 3x. Multiply this side by 3x. Okay, so when we multiply 3x times 2 over x, the x's will cancel out and we'll just have 6. When we multiply 3x times 4 over 3, the 3's cancel out, so we have 4x. And on the right side, nothing cancels out, so we have 6x. So solve it, subtract 4x on both sides. This is linear, so we're just undoing. And we get 6 equals 2x, and then divide by 2 to undo the multiplying by 2. You get x equals 3. And if you plug that back in, 2 over 3 plus 4 over 3 is 6 over 3, which is equal to 2. So it does in fact work. All right, so when we don't have a proportional rational equation, we need to go back and look at LCDs like we did when we were adding and subtracting. Okay, this time we're just multiplying every term of the equation by that LCD. Okay, and what happens is it cancels out all the denominators then, and it just changes your equation into either a linear equation like this one, okay, or a quadratic equation like the last one.